Welcome to the second presentation in Unit 4 entitled Hello, My Name Is. It says experience is simply the name we give our mistakes. Oscar Wilde. So the learning goals for this presentation are that you be able to name ionic compounds given the chemical formula and write the chemical formula given the name. Now, what we already know. We already know that cations are atoms that have lost electrons to satisfy the octet rule. So something like sodium. It originally has one valence electron. It loses that valence electron. Whenever it loses that valence electron, it becomes a plus. Okay, anions are atoms that have gained electrons to satisfy the octet rule. So normally chlorine has 7 valence electrons, and it gains that one electron from sodium, and as a result becomes chlorine minus. We also know that opposites attract. So here's what we learned in the lab. Ions can exist as monatomic ions or polyatomic ions. Cations will always attract anions, so you'll see this attraction here. The charges between the cations and the anions must balance to zero. Everything must be neutral when we're all said and done. So, the number of compounds. 114 elements can be arranged into many different compounds. There are an estimated 30 million different chemical compounds, and all of them you need a unique name. Because if you mean sodium hypochlorite, and there's 3 or 4 different things that fall under the name sodium hypochlorite, it won't work. So you need to be aware of that. You need to be able to use the polyatomic ions chart. There is only one polyatomic cation, and it's right here. It's ammonium, NH4. Every other polyatomic ion is going to be an anion. You need to be able to use this chart. You're not going to be asked to memorize any of these things, but you need to be able to say, oh, CN, that's cyanide, or chlorate, that's ClO3 minus. So the names and the formulas will be given to you, but you need to be able to use this to write and make chemical formulas. So when you write or when you name an ionic compound, the first thing you need to do is you need to determine the metal cation, and that's always first. And in this case, it's copper. So you may not know that Cu is copper, but you have a periodic table. If you look at and find Cu on the periodic table, you'll see that it's copper. Next, you would look and see if the metal is a transition metal. Remember, that's groups 3 through 12. You have to have a Roman numeral that goes with it. Now, the Roman numeral that goes with it is the charge of it. Now, this is the most important step because this comes from the idea that everything must be neutral, which means it has to add up to a total of 0. So I look at this. Chlorine is in group 17, so each chlorine has a charge of -1. Because there are 2 chlorines, though, that each have a charge of -1, the total charge of my anions is -2. So that means the total charge of my positive has to be +2 as well. But I only have 1 copper, so what that means is the 1 copper has a charge of +2. So the Roman numeral goes 2. Now, if you're not familiar with your Roman numerals, as a quick review, you have 1, which is an I, 2, which is an II, 3, which is an III, and then at this point you go to 4. The V stands for 5, so by putting a 1 before the V, you're saying 1 before 5, which is 4. Okay, then you have 5, 6, 7, 8, 9, and 10. Naming ionic compounds. All you have to do is name the anion, replacing the end of the element name with "ide." So for example, this is chlorine. Whenever it's chlorine, I replace the "ine" with an "ide," and this becomes copper 2 chloride. Or if this is a polyatomic ion, you would just name from the chart. So you could say something like chlorate or cyanide or something along those lines. But if it's an element by itself, all you have to do is replace the last part of it with "ide." For example, if it was nitrogen, I can replace the end and I can say nitride. It takes some practice to know that it's not nitrogide, but it's something that you get used to as you go through the process. So say what goes first in an ionic compound? Always positive first, always negative second. So it goes positive and then negative. It says write the name of the chemical formula for the substance below. So you would go to your polyatomic ions chart. So I look at acetate, and there's actually 2 different ways to express acetate. I like this one better, CH3COO minus. It has a minus charge. You could have also written it as C2H3O2 minus. Either one is acceptable. This is the one that I prefer, but either one would work. And then you'd look on your polyatomic ions chart and you would find this and you would recognize it as cyanide. It says name the compound below. So the first thing I need to do is I need to identify which one of these is positive. And this right here is my metal. So I would say that it is, first it's going to be FeBr3. That's my chemical formula. And so now I would name this. I name this as iron using my periodic table. Iron is a transition metal, so I'm going to have to specify its oxidative state or its charge. Oxidative state is just another word for charge. And then I would find bromine. Bromine is in group 17, which means that each one has a charge of -1. There are 3 of them, so the total charge on the right is -3. Now remember, everything has to add to 0. So because of that, I need a charge of +3 on the left. There is only one iron, so all +3 must come from the iron. So iron 1, 2, 3, and then chloride. Oh, excuse me, not chloride, bromide. So one of the things that you'll notice is I don't actually specify how many bromides there are. I just say iron 3 bromide. Okay, so that's how we develop, or that's how we write names for ionic compounds. And the last one, it says write the name of the chemical compound below. So we have to look at this thing and say, okay, I know this is a polyatomic ion. Because it's a polyatomic ion, I have to go to my chart. I know that this, if I look at it, is copper. The total charge has to be 0. So I look at it and say, okay, the first thing I'm going to do is I'm going to say that it's copper. I know that copper is a transition metal, so I'm going to leave parentheses to put the Roman numeral there. I look up this on my chart, and it is dichromate, and it has a charge of -2. But there are 3 of them. So because of that, the total charge on the right is -6, which means the total charge on the left has to be +6, because it has to cancel out to 0. But this time there are 2 coppers. Because there are 2 coppers, not each one of them is going to have a charge of 6. Instead, they have to have a total charge of 6, which means that each one of them has to have a charge of +3. So I'd write it as copper 3. And then this right here I get from the polyatomic naming list is dichromate. Next, you should be able to write the chemical formula. A chemical formula is a shortened version of the name, and it's really useful when we talk about chemical equations. So you can see it in terms of colors. If this thing is G2W2, because there's 2 greens and 2 whites. This right here would be blue, and then 3 yellows. So you specify how many of each one there are by what's called a subscript. So the combination of elements with subscripts identify the number of each atom. So when you write the chemical formula, the first thing you do is you identify the cation, and you write the chemical symbol for it. So this right here would be iron, Fe. Next, what we need to do is we need to write the charge of the cation. Now, what you would generally do is you would follow the pattern. If it's in group 1, it'd be +1. If it was in group 2, it'd be +2. If it was in group 13, it'd be +3. But because iron is a transition metal, group 3 through 12, I need to read the Roman numeral. So I would say 3 is +3. Then I need to name the ion. Okay, now in this case, this is a polyatomic ion. It's not chloride, it's chlorite, which lets me know it's a polyatomic. So then what I do is I write my polyatomic ion, including the charge. So whenever you have just a minus by itself, that means -1. So I have a charge of +3 and a charge of -1, and that is not neutral. Instead, it has a charge of +2, so that doesn't work. So the last thing I need to do is I need to balance the charges because they're not equal. So the easiest way to do this is to crisscross. You take the 3 and you move it here, and you take the 1 and you move it here. So I would have something like Fe1 ClO2 3. Now, whenever we have a 1, we don't write it because it's just understood at that point. So what we get is this right here. This is the chemical formula for iron 3 chlorite. So it says, what is the charge of tin 4? You have to recognize this as a Roman numeral, and that it would be tin 4. Now, all of these things, all the Roman numerals are always going to be cations, so it's going to be 4 plus. So it has a charge of +4. It says write the chemical formula for aluminum oxide. So I find aluminum, that's Al, and because it's in group 13, it has a charge of +3. I look at oxygen. Oxide just means it's an element by itself. It says O2 minus. Those charges are not balanced. So because they're not balanced, I crisscross. And when I crisscross, I get Al2O3. And that's our formula for aluminum oxide. Next, you have write the chemical formula for barium phosphate. Well, I look at my periodic table and I find that barium is Ba. It has a charge of 2 plus because it's in group 2. And then I look at my polyatomic ion sheet and I find phosphate. Phosphate is PO4, but has a charge of -3. These are not balanced. Because they're not balanced, I crisscross. And it becomes Ba3. Now I'm trying to say that I have 2 of these things, phosphates. So what I do is I put parentheses and I write phosphate, and then I say that I have 2 of those whole things. If you were to just write PO42, it looks like you're saying that you have 42 oxygens, not 2 phosphates. Finally, it says ammonium has a charge of +1. What is the charge of each element? How is this possible? So if you were to look at it, ammonium is N, and then H, 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 and the whole charge is +1. Okay, so if you were to look at this, everything has its octet rule satisfied, yes. But nitrogen originally had 5 valence electrons. Each hydrogen has 1 valence electron. So when the hydrogen comes in, they have a shared pair. When the hydrogen comes in, they have a shared pair. Hydrogen comes in, they have a shared pair. Hydrogen comes in, they have a shared pair. So right here you've got hydrogen. So you've got these right here. The problem is this right here. This extra electron right there makes it so it no longer satisfies the octet rule. So that electron has to leave. Whenever that electron leaves, you've removed an electron. Whenever you remove an electron, it becomes +1.